So again, I'm going to run through all of these. Okay. I'm going to do them in order of ones you need to know for the quiz for Thursday and then everything else. So this one here, you need to know for the quiz. Okay, this one here. Turning to the next page, backside, perpendicular bisector. Those two are kind of ones that you see a lot. Those are ones that you are going to need to know how to do. Okay. So one more time. Bisecting an angle, perpendicular bisector. Now, you're going to have a choice. You're going to have a choice of 3 different ones you can choose one of. And one of those that you could choose is an equilateral triangle. That's one of them. Okay. Another one that you can choose, I'm going to turn to page 9. Another one that you can choose is hexagon. And the last one that you could choose is copying an angle. So those are the 5 I'm going to start with, and then we'll go through all the others. Okay. So let's go back to page 7, bisecting an angle. An angle, that means cutting it in half. So what you're going to do first, and we're going to write here what to do. What we're going to do first is you're going to pick a radius for your compass. That radius has to be able to, if I do a circle centered at B, it touches both sides of the angle. So you don't want something that's too big, that's not going to intersect the angle. That's too big. You want something that's going to intersect the angles. So I want to pick a radius that is going to intersect both sides. So pick a radius, okay? And then at B, at the vertex here, you're going to make a circle. And when I say make a circle, maybe we don't make a whole circle, okay? What I want is I want it to intersect both sides of the angle. And where it intersects both sides of the angle, I'm going to put 2 points. And I'm going to label them as a reference. Since we already have an A, C, and D, let me just call this one D. Let me just call this one E. Just as a reference, just to have something to refer to, okay? The next thing we're going to do is we're going to take our compass, keep it the same radius, keep it the same radius. And at E, we're going to make a circle. And at D, we're going to make a circle. Now, our goal is to cut this in half. So when I make my circle, I want to make my circle in between the 2 lines. That was at E. I'm going to come to D. I'm going to do the same thing. And I get where those 2 circles intersected. So from here to here, this was centered at circle E. This one was centered at D. Where they met right here, I'll call it F, again, just to have a reference. That point would be a 4th side of a rhombus. We really constructed a rhombus, okay? But we don't need the rhombus. What we need is our angle bisector. So I'm going to connect B through F. And that line is my angle bisector. That's cutting them in half. Okay? That's cutting it in half. Now, when we are trying to do this, here it says how to do it. So we're going to write out the steps. Okay. The first thing I did was pick a radius that will intersect both sides of the angle. Okay, so again, don't pick something too big that is not going to cross both sides. Then what we're going to do is we're going to draw a circle at B with that radius. So that was this situation here, okay? Once I did that, it crossed in two places. Then at D and E, draw two more circles with the same radius. So we got this point D and E when we had that circle intersect the angle. I kept the same radius that I used for that circle, and at E, I did another circle right here. Then at D, I kept that same radius and I did another circle right here. Where they meet is point F. The last thing you need to do is draw a line from B through F. And you can extend it beyond, because this angle, that single bisector, is a line that goes on forever and ever and ever in that direction. It's really a ray. So now we're going to turn to the next page, and we're going to look at this perpendicular bisector. Okay, perpendicular bisector. So for this perpendicular bisector, perpendicular means it meets at 90 degrees. Bisector means it cuts it in half. So what we're going to do is you're going to pick a radius. Now, it doesn't really matter what size radius you pick. However, you want to make sure that when we draw a circle centered at A and we draw a circle centered at B, that those two circles meet. So if you choose a radius that's less than half the distance, they're not going to meet. So you want to pick a radius that's more than half the distance. So pick a radius that's more than half the distance. Okay, I'd rather go bigger than smaller and be like, well, it's almost half, and then you find out it's not. Okay, so pick something that's going to be more than halfway. And what we're going to do is we're going to draw two circles. And when I say draw two circles, again, we don't have to necessarily draw a whole circle. I'm going to draw one at A, and then I'm going to draw with the same radius at B. Now, what I really need is I'm trying to get it to be somewhere here, obviously, to bisect. So I don't need to go outside of B like this, and I don't need to go outside of A. So if I'm here, let's say at B, I'm going to go below the line. Now, if you want to draw all the way like this, you can. And go above the line, you can. But I know sometimes some of us are struggling a little with the compass, the control of the compass. So you don't have to do all of that. What you can do is mark below, but make sure you go beyond where you think the center of the line is, and mark above. You can just do that. Okay, and just give me this mark and this mark if you want. Then I'm going to pick up, and from the other endpoint, I just did it from B. Now I'm going to do it from A. I'm going to do the same thing. And again, I could go like this and draw that whole thing, or I can just do this and make sure I see where they cross, and do this again to make sure I see where they cross. Then you're going to get 2 points. where they cross. I'm going to call this one, let's say C, and let's say I call this one D. Once you get those 2 points, the one below where the circle crosses and the one above where the circle crosses, what you're going to do is you're going to take your ruler and you're going to draw a line connecting those, D and C. And again, this is going to be perpendicular. That's what the perpendicular means, 90 degrees. And bisecting means it cuts it in half. Now I'm just going to get a little sticky note to use as my 90-degree test here. So you see it was 90 degrees. Okay. So again, you choose a circle radius that's more than half the distance from A to B. From B, we're going to mark below the line and above the line. Then from A, I'm going to do the same, below the line, above the line. Where they cross, I connect those 2 points. That is my perpendicular bisector. So I'm going to write down the steps. So step 1, pick a radius more than half the distance between A and B. Okay, again, it does not matter what that is, as long as it's more than half the distance. Then what you're going to do is you're going to draw a circle with that radius at A and another at B. And I'm going to put it in parentheses, need above the line and below the line. Okay, so we need to go above the line, we need to go below the line. Then what we're going to do is we're going to connect a line through C and D. And again, C and D are where the 2 circles met here and here. And that is our perpendicular bisector. So let's take a look at the equilateral triangle. So what we're going to do for the equilateral triangle, you're going to draw a line segment. And we're going to have that line segment be the base of your equilateral triangle. And just to make sure everyone understands what an equilateral triangle is, it's a triangle with all 3 sides that are the same length. Okay? So I'm going to pick a radius. A length for my line segment. Don't make it too big because it needs to fit a triangle in this box. Okay? So I'm just going to draw a line segment. I'm going to put endpoints on it. Maybe I call this one A, let's call this one B. Okay, so I just drew a line segment with my ruler. Now, if I talk real quick about this. When we are doing the perpendicular bisector, all of these end up on the same line. So I could have drawn a triangle from A to here and to here, or from A to up here and down here. All of those would have been what we call isosceles. 2 sides are the same. So we saw that here when we were doing these, that anywhere on this line, if I pick a point anywhere on this line and I connect it to both endpoints, I'm going to get isosceles. Both of these sides are the same as each other. For this triangle, both of these sides are going to be the same length. These are going to be the same length. But we want that length to not be just these are the same. We want the same as our base. So unlike this, where we randomly chose a radius, as long as it was more than halfway through, I'm going to choose a particular radius. I'm going to choose a radius. That's the length of AB. Let's get AB as our radius. So I'm going to get AB as my radius. And then I'm going to do almost like the perpendicular bisector, but I don't need to really go below because I'm going to be making a triangle. So I'm going to get this as my radius, okay? Get this as your radius. Once you get AB as your radius, you're going to draw a circle at A and a circle at B. Now, I'm just going to go above. I don't need to go below. So either I can do like I'm doing here and draw an arc above, or I can just come and mark up here. I did that one at B. I'm going to now do it at A. Okay. And when I do it, again, I'm doing this part of this arc here, or I can just do a marking like this. Where those intersect, that is going to be my point C. That point is the distance from A to C, which is the radius of this circle, but it's also the same as the radius of this. Okay, so you see here, this circle that was centered at A has this as a radius, but if I draw from A to C, that would also be a radius. So they're equal. And if I'm looking at this circle I drew from B, here to here is the radius of that circle. But if I draw from here to here, that's also going to be a radius. So these are equilateral. But again, you want to make sure that you don't choose a random radius. You need to choose a radius that is AB. So then I'm going to connect from A to C and from B to C. And there's my equilateral triangle. So what we're going to do so if I'm giving a list of how to construct this, my first step was draw line segment, and I'm calling it AB. Draw line segment AB as base of triangle. Then what I'm going to do is I'm going to get AB. Now, when I write AB without a line segment over it, this means length of AB, measure of AB, okay, the length of it. So I want to get the length of AB as radius of compass. And then I'm going to draw a circle with that radius at A and also at B. And I'm going to put in parentheses, need above. Just do it above. You don't need to go above and below like we had to for a perpendicular bisector. And then your last step is to connect a line segment from A to C and B to C. And that might seem obvious, but so many times I'll have people do all the compass stuff and not give me the actual answer, which is connecting those points and making your triangle. Okay. So I want to see that triangle. Now make sure you don't erase the markings. I need to see the markings. That's your construction part. But you also need to actually connect so we see our equilateral triangle, or we see our perpendicular bisector or angle bisector, whatever they're asking you to make. So on the construct a hexagon, what we're going to do is we're going to put a point. Speaker mode. We're going to put a point as your center. Okay, put a point. I'll just label it C for center. Okay. And you're going to pick a radius for your compass that's going to fit on your page. Okay, for your circle. So pick a radius and you're going to draw a circle with that radius centered at C. Okay. Let me just get my. So whatever that radius is, we're going to get that circle. You're going to draw your circle. Huh? So you're going to get your circle and make sure you have your center. That way, if you have to remeasure your radius because you moved it by accident, you can easily do it. We don't have to find the center. So we're going to keep that radius. And what we're going to do is let's put a point anywhere on your circle. I'll just call it A. Okay. And then from that point, I'm going to start by drawing a circle with that same radius. Now, when I say draw a circle, I really care about it crossing my circle. So I'm going to make a mark. I'm going to pick up. I'm going to go to that point. I'm going to make another mark, and I'm going to keep going. Okay, I'm going to keep going. All the way around your circle. So I started here, and then I made 1, 2, 3, 4, 5 circles because this one here would have been my 6th one. It would go back to here. And so I have a point here, 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 and here. So again, the radius that I used was the same radius I drew the circle with. I put a point anywhere on my circle, and then I started drawing circles, touching this circle as I'm going, restarting a new circle from each of these. Once you get those 6 points, you're going to connect them. You're going to connect those 6 points. So I'm going to connect. Let me do this in a pen so you can see it a little better. You're going to connect all of these together. We're really splitting this circle into 6 equal pieces. And if you take a circle and split it into 6 equal pieces, you're going to get actually equilateral triangles if I was to connect all of these to the center. So if I was to draw each of these to the center, I get 6 equilateral triangles. You're going to see that in integrated 2. And then there's my hexagon. So in terms of steps, first thing what I did was put a point C. And again, you have to use my letters. I'm just having as a reference. Put a point C for center of circle. Okay. Pick a radius and keep it throughout. And draw a circle centered at C. So again, I put this down, I pick a radius. I make sure I keep that radius throughout this problem. I use that radius to draw the circle that I originally started with, the one you see in pencil. Then, once you've done that, you're going to put a point, I'm just calling it A, on circle, and start drawing circles. Oops. Start drawing circles. Clean that up. Start drawing a circle at A, then continue drawing circles from each new mark. So again, at A, I drew a circle. And then from that mark, I drew another circle, and from that mark, and from that mark, and so forth. And then the very last step, you want to make sure you actually answer the question and do what they're asking. Connect all 6 points to form your hexagon. Okay, connect all 6 points to form your hexagon. So just a little reminder, if we wanted to do an equilateral triangle in a circle, we could. Okay, so to get an equilateral triangle, I'm just going to abbreviate triangle with a triangle. Using this method, the only thing different is you're going to connect every other point. Connect every other point. So I'm going to do that with just a pen. So the hexagon is my answer. But what I could have done, and it doesn't matter what points I start with, let's just say I start with A, and I'm not going to connect to here. I'm going to skip that one. I'm going to connect to the next one. And then I'm going to skip and connect to the next one. And skip and connect. And then I get my equilateral triangle. Okay, so I could also do an equilateral triangle that way. Again, we're asked to do the hexagon, okay, but you could also have done the equilateral triangle. So again, the ones that you can choose, the equilateral triangle, the hexagon, copy an angle is the third one. So to copy an angle, what we're going to do is the first step is to get a line segment. I get a line segment that's at least as long as this or longer. It doesn't matter the length of it, but I wouldn't make it shorter than this. Okay. So I'm just going to draw a line segment. Okay. Let's say I do it down here. I'm going to draw a line segment. And for my line segment, I'm going to just kind of label this. I'm going to label this. Let's say I label this A. Okay. I'm going to label this A prime. So I'm going to label this A. I'm going to label this A prime. Now, to copy an angle, it's kind of a little similar to what we were doing for a bisector, but of an angle, but not exactly the same. You're going to choose a radius. Again, you want to make sure that it's going to intersect both sides. Okay. So you're going to choose a radius at A. I'm going to draw a circle centered at A. Again, making sure it crosses both sides. And I'm going to label this, let's say B, and let's say I label this C. Okay. I'm going to keep that same radius that I had here. And I'm going to come here and do the same thing at A prime. Now, I don't know how far to stop because I don't have a line drawn here. Just draw beyond where you think that would go. Okay. So I'm going to overemphasize. I'm going to draw beyond where it needs to go. That's definitely bigger than I needed. Okay. So again, picked a radius over here for a circle that's going to intersect both sides. I came over here to A prime, which corresponds to A. And I did that same circle, but centered at A prime. Now, I'm going to call this B prime because it's going to correspond to this. This line segment AB should be the same length as this one, A prime, B prime, because I kept the radius the same. They are the same. Now, where people go wrong is I'll have people just randomly draw a line to that. Now, I could draw an infinite amount of lines to this circle, but how do I make sure it's the same as this? What I need to do is I need to measure. I need to measure the distance from B to C, not with my ruler, but with my compass. So I'm going to get my compass and I'm going to use it as a ruler. I shouldn't say ruler, but as a measuring tool to get this distance as my radius. Okay. Again, I have to shift my compass to get the radius here. They may not be the same. Chances are it's not the same as what you had before. I'm going to just make sure that I have the right radius. So you see that that's going through that point. So that's the distance I need. Okay. Notice how it's crossing this circle. That's what I need over here. So again, I did this at B. I got the measurement and then I made a mark. So I'm going to come here to B prime with that same radius and I'm going to make a mark. So again, I measured this, getting that as my radius from B to C. Had to probably shift my compass. Then I came over here and that circle I would have drawn at B is intersecting right here. Well, I want to see that over here. So I draw at B prime. And I get this point here that I'm going to call C prime. That corresponds to this C. And then I can take my ruler and connect A prime to C prime. And there's my angle. We do the steps. So first step I did, draw a line. And I labeled one endpoint A prime. I'm labeling whatever one's going to be your vertex. Okay, this is a vertex over here. Okay, this one at A. Then pick a radius that will intersect both sides of angle. So again, you want to have it intersect both sides. So you can get these 2 points, your B and your C. use that same radius. Okay, well, I should say this first. Let me just draw a circle centered at A, and then do the same centered at A prime. Okay, where A prime's right here. Then what we're going to do is we are going to get BC, the length of BC as our radius. Get length BC as radius. And then draw a circle at B prime, okay? So again, I measured here from B to C. I really had my compass at B, stretching it to C. That would have been a circle that I would have drawn. I transferred my compass to here, and I did the same at B prime, and that's how I got that mark, which gave me my C prime. And number 6, connect a line from A prime through C prime. And I say through because it doesn't have to stop there. The angle keeps going forever and ever and ever, so it doesn't have to stop anywhere. You don't need the same length for the line segment. You're concerned with the in-between. That's what you're concerned with, the in-between. Okay, so we're going to now go back to page 7, and now we're going to go through the rest of them, starting with copying a segment. Okay, this is on page 7. So to copy a segment, what you're going to do is you're going to draw a line that's longer than the line you need. Okay, so you're going to draw a line segment. It doesn't even have to be like parallel to it or anything like that. Just draw a line segment. Longer than you need. And I'm going to label one endpoint as D prime. Okay, that's going to correspond to the other D. First thing we're doing, again, for copying the segment, draw a line segment, make it longer than you need. Make it longer than you need, okay? And then I just labeled one end D prime to correspond with this D. This is from the back side of my page, okay? So I am just drawing a line segment, and I'm just labeling D prime to represent the same as D, okay? Corresponding. Now, what I'm going to do is I'm going to get DE as the radius of my compass, okay? I'm going to get DE as the radius of my compass. That's how I'm going to measure it, okay? So I'm measuring from D to E. And then I pick this up and I go to D prime and I make a circle, okay? And that distance here is the same as this distance here. So again, I got a radius of DE on my compass. I personally measured from D to E because I'm going to draw it from D prime. And I made an arc. And where that arc touches, that's going to be my E prime. And I'm just going to highlight this. This from here to here, that's my line segment. That's my line segment. So in terms of steps, draw a line segment longer than you need. Okay, we're going to draw one longer than we need. We don't want to be too short with it. And label one endpoint D prime. And you don't have to use my letters in the sense of, you know, when you have your own. I'm just trying to emphasize so we can follow where I am on the picture. But if they label this D, I would label this D prime. Okay, because those correspond. Then get DE, and again, when I write it without a line segment across it, I mean the length of DE. Get the length of DE as your radius. Then draw a circle with that radius at D prime to find E prime. And then that's your answer.